This video will focus on the target. I can compare and contrast the planetary model to the quantum mechanical model. So looking at both the quantized energy levels as well as this electron orbit idea. So the progression from the planetary model to the quantum model has to do with these problems. For the planetary model, electrons are going to be orbiting the nucleus in concentric rings. The problem with those rings are that we found electrons can't move in rings based on physics. Okay, the electron is so tiny, the nucleus is so massive and so positive, the electron should just collapse into the center. The fact that it doesn't would tend to lend itself to the idea that it's not moving in these rings in the solar system way. The other problem is this model did not account for the idea that the electron was both behaving like a particle and a wave. Okay, if all of it's doing is hanging out on this ring going in a circle, that would tend to be a particle model, but the wave was not acknowledged. The other issue, again, was that Bohr was unable to calculate the energies of any electron in any atom that wasn't hydrogen. So his model didn't work mathematically for anything but hydrogen. And then we got Heisenberg coming in about this whole position and direction with the uncertainty principle. Now, how Schrödinger changed things then was we find electrons now reside in areas of probability rather than orbits. So the electron is not traveling in a defined path. Instead, it's traveling like a wave within these areas of probability. So that's the big change, okay? That electrons are now in orbitals instead of in orbits. So when you think about these two models and you want to compare and contrast both like how they deal with energy levels and how they deal with electron location, both have energy levels described within their model. Okay, so for Bohr, we have these quantized energy levels shown in different rings. If the electron moves to a ring that's further away, you've changed energy levels. In the quantum model, we deal with it in multiple ways. One way we can change energy levels in terms of just within 1 over principal energy level is you can change orbitals, right? You can go from an S to a P. That will change the energy associated with the electron. The other thing you can do, and you can tell from this picture, is you can change energy levels very similar to Bohr. Every orbital, right, has a principal energy level, 1, 2, 3, 4, and if you go from like a 1 to a 2, you do go further away. So the quantized energy levels are in both models. Okay, the Bohr model shows it with the concentric rings. The Schrödinger model shows it with different orbitals. If you're going to change orbitals, you'll change what your energy level is. The big change then is how they talk about electron motion. For the planetary model, we have electrons moving in a circle around the nucleus. And for the Bohr model, we have them moving as a wave within their areas of probability. So we have orbitals coming into the Schrödinger model where we have orbits in the Bohr model. And that's a huge thing about location. So both have energy levels, both have quantized energy levels, but in terms of how electrons are moving or where they're placed, totally different. Bohr has them moving in circles, quantum model has it moving in waves. Bohr has them in orbits, quantum has it in orbitals. That's it. Have a nice night.